Welcome to episode 2 of In the Mix. Today's episode is about GRC, the material and the mayhem, and I'm really excited to have our guest here. If you'd like to introduce yourself, Simon.
Yes, thank you for allowing me to get here. My name is Simon. I am from Denmark, so apologize for Danish. English not being my first language. I've worked in GRC industry for 11, 12 years, and mainly as a Danish supplier of GRC, manufacturer of GRC, and also in 6, 7 years as chairman of GRCA. So I've been a part of writing the latest Euro norms on GRC production and testing. I was a part of that group, including obviously some from UK as well. That's pretty much the introduction of me.
So that's what you've done typically, and more recently you have now moved into a consultancy role.
I stepped out of the Danish manufacturer and have started a small little one-man army, just me being a consultant and also supplier of some of the special raw materials. Was lucky to get a chance to be able to supply a part of that, and also I've apparently get involved into as a normal consultant. That could be a building job where people are having a conflict whether something is a mistake, is it then a production mistake, or is this fair? You know, that kind of typically I could imagine contractual things.
Yeah.
Where before you end up in a lawsuit, you maybe could ask for an opinion for someone that's worked with it for a period of time. My focus in those kind of jobs is to find a way out of it, because I've been on that side of the table where it's, nobody's earning anything of having those fights.
Yeah.
Everybody would love it to work, and it's also about, calibrating expectations and how do we then handle it and all of that.
Yeah.
That's my task.
I think the work that we're doing is a little bit in tandem. I suppose I'm trying to support the architects and the contractors from a commercial point of view to try and sort of drive specifications and create the interest.
Yeah.
And obviously the sort of experience and the knowledge you have, as you just said, you want to get involved in active projects, you want to raise the standard of GRC, you want to help people understand the capabilities and things like that. So I think the work that we do is, of the same goal, I would say. We're trying to sort of do something for GRC in the UK, Europe and internationally that isn't currently happening. So it's, we are on the side of GRC,
The first interesting thought one will have to have and discussion is, what is GRC? Is it a material? Is it a product? Because we are talking right now, raising the industry standards on facade components.
Yeah.
Be a balcony floor, ceiling. It can be a front. It can be just a facade panel. It could be a staircase. It can be things on typically outside of a building. Obviously, could also be used for interior decorations. But it is used throughout the world as a lot of other things.
Yeah.
You have one big company here in UK that actually makes a lot of railway tiles or components to the railway systems. Obviously of a different property, because that is not meant to be aesthetic, it's meant to for other purposes.
Yeah.
You also use it in South America for water drainage systems, you use it in France for electrical post, so you can cover boxes. You use it in a lot of ways, and even furnitures, outdoor furnitures. So the first thing, the discussion is are we talking about GRC as the product on a building, typically as a facade product? Because then we can start to have a more concrete discussion on raising the standard. Because the rest I honestly don't know that much about, but it's just interesting. And it's also the answer why a lot of people typically ask, why is this not CE marked? We use it more and more, but it's not marked to any, where's the standard? That's why you're now doing this job, trying to make a podcast about it, making white papers about it. The GRCA has specifications and that's just a trade association making their own kind of endorsement of it. Why is that? Well, that's because it has this problem that it's kind of being perceived as a product, but it is a material. It's a mix. And you can mix it in so many ways and use it in so many things. And obviously, is it meant for aesthetic? You need to discuss the, color variations and buckles and things like that. Installation. Then you need to discuss, tolerances on fixings and backside and how do we do static calculation if it sits somewhere, if it's load bearing. How do you then calculate that? That's a big part of it, that you need to define it a lot. That's let's say that's one of the issues GRC is fighting with, that there's this misunderstanding.
Yeah.
To make that even more complicated, I would add on the discussion on UHPC and GRC. So UHPC is ultra high performing concrete. GRC is glass fiber reinforced concrete, and it has a very high performance. So why isn't it not a ultra high performing concrete? Well, GRC we at least have a definition on, because that's glass reinforced. It has to have some glass to reinforce it, right? Otherwise, it won't be GRC. But UHPC is fighting a lot in between the many interested parties on when it's only a high performing concrete, when it's a ultra high performing concrete, and it's primarily focuses on the compressive strength. GRC has a very high compressive strength, but you don't want to put glass fibers in to get it, because that'd be way too expensive. There's a lot of cheaper way to get a high compressive strength. What you want to put glass fibers inside, the expensive glass fibers inside, is for the tensile strength. So you're already there comparing two different things. On the UHPC, if you have a load-bearing thin, let's say a balcony, you could find things where GRC will not be the superior material, because that strength over there in typically steel reinforced UHPC will be better. But if you are talking about a facade cladding, why on earth would you then, if it's not stacked on each other, so it's not load bearing other than its own weight and then wind, suction and pressure, why would you then make it any thicker than needed? It's more energy to make it, more material, more weight, more handling, more weight on the building, thus bigger constructions. And I see both things happening. I see GRC being designed, it has to be GRC, where you could have used a UHPC easily. And then I see a lot of UHPC facades where you could easily have done that with GRC. And that's a part of the whole discussion, that one is selling on compressive strength and the other one is selling on tensile strengths. And that's a part of that's another thing that the GRC is fighting with, right?
I think for me, you've touched on some really important points there, because in the UK, what I've found from the commercial point of view, dealing with architects, contractors, installers, there's definitely a lack of understanding in the industry, in the difference in materials. That also includes precast. People are still confused when you've got precast concrete and GRC. People in the UK are very much behind, Europe and the rest of the world in understanding the differences of the capabilities of the load bearing that precast concrete can do and what GRC is capable of in facades. And then you bring in UHPC
just to add on
to the conversation, which does add to the confusion, but it's also very interesting because the larger the contractor and the larger the developer and the better understanding and technical capabilities they have, you see that is very well understood. It's a case of, which is something that as Link GRC we're trying to be involved in, is rolling out that education of the materials and what they are capable of. In my recent magazine, I did a feature on precast concrete and GRC not being identical twins. They are cousins. They have similarities in the basis of materials, but they are not cut out for the same graft. When I have somebody that will contact me with a precast concrete specification and potentially want to change that to GRC, they're some of the first questions that I ask. Is your precast concrete, what is the design? Is it even, is it something that we can look at changing? Because some people don't have the understanding of what that is. So I think it's important.
And that's totally understandable, at least from my part, why there's such confusion. I came into the industry as a former lawyer. I knew nothing about concrete or manufacture. It's by coincidence. Long story, I'll spare you for that. But I ended up in a production in Denmark. And I needed also things to be put in line. So first off, when you manufacture GRC, you can do it by 3 methods. You can mix, it's called pre-mix. So the fibers is already cut into a certain length, and you can put it in a certain amount. If you put in too many fibers, it won't flow, so it'll be difficult to put out. But you can, of course, then add different plasticizers or other. You could have a very different mix, but you can put that in.
Yeah.
And then that's called pre-mix. You'll then add on that to your mold, or you'll actually you could make that, just like on an in situ concrete. Then there's a spray, and that's different because the glass fiber is one long line, continuous line, that are then being chopped. So what that does is that the armament is now being documented evenly dispersed. Whereas the premix, how would you document that you are, let's say, 3.5% of fibers is not tin over here, nothing by you?
Yeah.
How do you know that? Well, you know that by mixing that, and you can look and you can take some tests. But when you have a gun that sprays out the mix of the concrete and then cut simultaneously the fibers and disperse that into your casting mold, you know your fibers is evenly dispersed. One thing. The second thing is the orientation of the armament. When you put canoes on a river, they will orientate themselves. If you have something that's longer than it's wide, and then your concrete mix, a premix, is then putting into the mold, in a corner one can imagine how the fibers will be orientated in one direction. Well, that gives a good strength in one direction, but nothing in the other direction, because you want the armament in all directions, obviously, to take that tensile pressure. Thirdly, you can add more, because you don't have to, it'll simply come, so you can have a higher fiber or armor content. So for those reasons, you can spray. Then there's, I can make a very dry mix. I can even spray it up, in difficult, in let's say, interesting curvature. That's also why people would then choose for the, I'm then saying that spray is way better. No, it gives you a higher strength. It's also more complicated and more costly. Not only the fibers, which is a big part of your cost base, you spend more fibers, but it's also just taking longer time. And there's benefits. You gotta find out, what am I making here and how will I manufacture it. Then there's the third, which is combination. That's a spray premix. So you have that mix with the fibers, and you have a gun that are then allowing the fibers to, or that flush or that slush there, to come with the fibers. That's not that popular, but it's possible. You can buy guns just for that. And there will be application where that's your thing to do. That's the first thing you need to put in the system. The second thing you need to put in the system is, what is this, the grade system? I needed to understand, it was grade 18. What does that mean? And grade 10. In a lot of materials called grade 18P. The P stands for polymer. The polymer is an additive that's a curing agent. It allows you to cure it only covered by plastic. If you didn't put on the polymer, you would have to cure it underwater. Nobody can cure concrete underwater. You would have a massive hole. It'd be a nightmare, right? So, but you could in theory, and in a laboratory you can do it. So that's why you put in a curing agent, and that's why it's called 18P. If you manufacture it without, you would have too many shrinkage, what's called cracks, and that's why you put in a curing agent. So what it does is that it creates a kind of, it goes to the surface and tries to hold the water, and it also fills out all these micro cracks. And that's your polymer. And when it's 18P, it means it has a characteristic mean value, get back to that, put a note on that, characteristic mean value of 18 megapascal. And then it's cured with polymer, 18P. It can also be 10P, it can be whatever. But if I'm making something that just is going, you just need to put that in your dirt, and tin is fine. And you don't care about micro cracks for whatever you need it for. It's just a tin.
Yeah.
It's pre-mixed 10
Yeah,
or
if
8
you're not
or
looking
whatever.
for the aesthetics or for it to be
It's
finished.
so back to that first discussion
Yeah.
as a facade. The typical would be 18. Why
Can I ask a
18?
question?
Yeah, of course, anything.
Is when it obviously changes then into rail or infrastructure or other items? Is there a set strength for that? Do they tend to use 8 or 10, or is that purely based on the individual item that you're making?
When Pilkington, and this is only what I've learned, right? When Pilkington developed this, so let's go back to 1950 something. As I'm informed, an Indian guy on a university in Sheffield were looking at the issues of putting glass inside concrete. So glass you can make as a rowing, and it has a higher strength compared to the thickness than even steel. So it's really good. But the glass, which is made of, as you know, sand that you heat up, cannot stay in a very alkaline environment. So when the pH level is very high, it will simply eat the material. So you could put in the glass fibers, you can, it's really good, and then wait a year or two. You would then cut your specimen over and look at the art, and you would just have some wormholes. Oh, all my strength is gone. So how to get around that problem? And as I've heard in the 50s, maybe early 60s, because Pilkington at that time being a massive glass manufacturer saw the industry, so they put money in the universities how to get around that. Mm-hmm. And the way to go around it was to make a glass fiber that partly consists of zirconium. Zirconium is a substance that if you have that periodic table, you'll even find it. It's found, and that we got a lot of it. It's not a rare commodity, but it's only obtainable in a few parts of the world. Okay. Which needs to be understood. And that he started, as I understood, with 25% of the standard sand being changed to zirconium, which is a powder. But now we are at 16%. So the glass fiber needs to be made out of minimum 16% in order for it to be alkali resistant. And what does that mean that it's alkali resistant? What it means, it can go inside that cementous mix that, because of the cement, has a very high pH level, can then still stay in there for a long period. And how long is that? Well, we say indefinite, but if you have a guy that'll make a paper, it'll probably say a few thousand years. Because the alkaline environment will stay there. That's a part of the cement. And any contractor or anything else that listens to this would probably recognize that if you got some mortar that you splash on the window, you got a week to clean it off. Otherwise, you will make a mark that when the sun hits right, you can see that mark. Because normal e-glass, which is the glass we can see through, will be eaten up by the alkaline environment, which is made out of cement. Yeah. Cement is also just being dug out of the earth, which is a calcium, and then it's of course through a massive process with a lot of other things. It's a big part of the problem is this process, that it has to have so much energy, high Celsius degrees, in order for it to become cement. And you then have some glass fibers that are made of sand. You got the cement, and then you mix that with sand, water, and you're pretty much to go. You can then put some additive in and explain, but that is your main thing. You put in the sand, you dig up, and you put in cement, which is also dug up, but of course processed. You mix that with water, and that's your concrete, right? And now you put a glass fiber made out of sand, in essence, zirconium as well, 16%, and that's your GRC. And this is also leading into my next thing. How do we define a color variance then? I typically ask my clients, could you please tell me the color on beach sand? Well, that depends if my kids just dig in it. Is it a sunny day? Is it a rainy day? Am I looking at the sand next to the waves or the sand up the beach? Well, it's that sand you can't define. Yeah. The manufacturer is receiving, obviously with some criteria. Even the cement would come with color variances, and there's no way you can, comes
scientific.
So it's impossible. Of course, you can mix it, and you could be really careful how you mix it, and you could have that. But if you don't want the fact that you are mixing natural ingredients, that comes with natural
Color
variances,
variations, yeah.
You need to color it afterwards,
Yeah.
paint it. But if you like that, and then of course you can work around that, trying to put different things in it, like your first show on putting a brick tile in the front. You could also done that with different things, like larger stones, or you could wash off aggregates so you can see the aggregates, play with the colors there. You can mix colors, obviously, in the cement mix. Typically, you use white cement for GRC just for that reason, because white cement comes with a lower color, still with some, but with a lower color variance than
some
gray.
of the
The gray cement typically is even more variable which type of gray. And then the white is also easier to color to whatever color needed. So a lot of gray GRC is actually white cement with probably a white pigment or maybe gray pigment or sand aggregate, and then some color, which is a concrete color. That's typically a powder, but you can also use it in. You can have it as a mix, a fluid, and you mix that in the colors. And the reason why you want to have that colored through is obviously, well, then you have it colored through.
Yeah.
So when you have maintenance marks or just the marks of time, you have that colored through. You have less maintenance to do in the color, and it also works out. And the interesting thing is that when you see a brick wall, we all love that. Oh, look how the colors are different on the clay, because we tend to accept that is
because it's a natural
clay
material.
GRC is very much a natural material, but you tend to, it has to be uniform. Well, some places, if you really need a uniform, you're either opting the wrong material, or you should have made it different in the surface, like painting it.
That's something that when I'm out speaking to architects in particular, I'm very careful to explain that to them. If they're trying to achieve very deep, very solid colours, like you say, it would be a procedure that is applied to the GRC after the production. It's not something you can achieve, but a lot of people that are using GRC and that understand it do understand that it is a natural material, and tend to use it in a lighter colour variation. But I am seeing more specifications of deep greens, reds and oranges in particular, pinks, salmons. That tends to be the new anthracite grey and white in the UK. The orange and
my
pink.
former co-owner back at the factory in Denmark, he's the son of the founder of that company I came from, and he had this. He made this speech at the GRCA World Congress, where he had this interesting point he was trying to make, or did make, that we have this. Everyone in the world is moving to. It's like the worldwide phenomenon. We are building more and more masses, and there's only really one way. That's building heights, and we do that, and we can have these dead facade that just are what we know we'll regret 50 years from now, which is just steel and glass. I'm not saying steel and glass building cannot be interesting, but of course they can.
Yeah.
But if you just make very uniform type of, high pressure laminate, no, that's not popular anymore, but those kind of panels that are just stacked on each other, and then there's
you need variation.
Well, you really need that variations in your building. And that's why the old buildings, I love those old buildings. Why did you like that old building? Oh, there's a big, there's nothing is identical. I know it's difficult to build a new building, then say, everything could be a patchwork. That's not what I'm saying. But I'm saying if you use natural materials for your products and don't cover it up, and you embrace that fact.
Celebrate the beauty of it.
Like you do on a tile, which is just why bricks and tiles are just in a different phase of selling that, because that's, I just love the brickworks. I'm looking out now on a brick wall, and I can't find two stones that are looking the same, appears the same. And there's thousands of them. And I'm not saying GRC should have the same criteria, but this is what
it needs to be understood for sure.
And accepted. And at least discuss what is then the acceptable and what is the design intent here. back to the grade 18P, because why is it then 18? It might as well have been 16. Well, there's really no good reason. Why not? So when this whole industry came up, Pilkington got this, as I knew it, Indian guy to develop it in Sheffield. Then the industry took over and needed, just like you're doing your work now, a group of people founded in UK the GRCA, a Glass Fiber Reinforced Concrete Association, trying to make sure how do we do this best. And a lot of what they then picked on there, they had to invent themselves. And they looked at the strength and said, okay, what is safe? Because you need something to, from there, say this is a safe spot.
Yeah.
To design something. You can easily make a GRC that has a higher grade. Maybe you can then call it GRC UHPC, but would there be a market for it? Well, I don't know. But the point is just to understand that as a designer, you could easily specify for 16 if that's what you need.
Yeah.
Manufacturers would probably say, why do you now need that, and where do I save the money to get in a lesser quality? But it's to set a bar, and the 18P is then the characteristic mean value that is measured by the 40 consecutive tests. So you take 40 test, and one test consists of a minimum of 4 testing. So you take 4 coupons, find, okay, this is my number, that's the average of those 4. This is my strength for this. And you do 40 of that.
Yeah.
And on those 40, you will get hammered if you have too high of variable, because you make what's called a same do, which means that you find the highest and the lowest of your 40 data sets.
That's your parameter.
And then you will simply take that distance and calculate your deviation. And your average could then be typically, I'd say, typically sits around 21 and a half megapascal in order to obtain 18 characteristic. So when a designer asks for 18P, he's asking for an average around 20 to 22, depending on the variations of said manufacturer, in order for him to document that on a 40 consecutive test set, consisting of a minimum of 4, he would have an average of characteristic 18. And that's how it was developed back then, that you needed to understand that there will be a variable. How do we then build that in? Well, if the average around 20, 21, what is then fair? And the whole same do is reasonable, because if you're, as a manufacturer, sometimes can make 27, which is possible, and then the next day make 15. Well, you don't know what you're doing probably, or is it your mix? Is it your supplier? It doesn't have to be you. As a supplier, it can be your raw material suppliers. It can be anything, your weather, whatever, and to put the market into a more consistent, you would then have this. That's how that was developed. This system GRCA took upon themselves to describe. They of course lent it from other, typically concrete materials, and build up this, let's say, paper set of rules that especially the UK market used. In Scandinavia, you would borrow the 18P, but not any of the rules. You would do it in a whole different way.
Yeah.
In Germany, you still do it in a whole different way.
Yeah.
And you can easily have a 16P. Would that be translated to a project in Germany? I've seen that, because that's the designers approaching it differently.
Yeah.
Oh, if I have this, I need this kind of material. Does anyone supply it? Instead of the other way around. And that's also to be understood.
Yeah.
Why is that? So it's not set in stones. It's industry made up that the 10 or the 8 and the 10 and typically 18, and the P is for polymer. That is to be understood as well.
In your experience, what would you say the difference is between a good GRC panel and a poor one?
Well, the Professor Peter Bartos have this really interesting way of putting things. He says, GRC is deceptively easy to make And the point he's making is that when you come in and see it, anyone that has had a career, put their hands into traditional concrete, also steel reinforced concrete, will say, what's the hard thing here? And it looks easy.
I did think that when I first in a GRC facility. I thought I could do this.
Yeah, but the thing is, you could, because it's just to explain you how simple it is.
Yeah.
But then there's so many tricks to it. So the armor is not stronger than how it is attached to, let's say, the other side of the crack. And if that fiber isn't put next to the concrete but just lies on top of each other, you can have the strongest fibers, the strongest mix, but the fibers won't help you.
Yeah.
And it's just, then it makes air bubble in one corner. Then when you spray, you could have typically what we call the chewing gum corner, is where if you weren't really careful about your mix, your little stones could kind of run ahead, and all of them would kind of mush up in one corner, and that would be, you have a little bit larger of the stones. One needs to understand, when you get the stones, you also get what's called a grade of the stones. So when I say stone, I mean aggregates, the fine sand. If you're from traditional concrete, you would think I'm crazy because that's larger stones, but we're talking sand.
Minuscule, yeah.
Yeah. And inside that, let's say I'm getting from 6 mil to even less. I get from 0.2 to 3-4 mil stones, because I need to get that out the nozzle of the spray gun. But how many percent of that is then the 2.5 mil, and how many is less than a mil? Well, I have a tolerance already there. But inside my silo or my big bag and in my mix, there'll also be, just like you imagine sand running down a silo, the larger stones will either come first or second. That depends.
Yeah, there's no process.
So there is happening a sort of what, I don't know the right word, but where you there's a choosing there that you need to understand that sometimes. Then you have the weather. Sometimes the sand is hot. Sometimes the cement is hot. Sometimes it's not. The temperature of the water, all these things you need to be able to understand in order to get a consistent mix, and then to make all the fibers touch all the GRC, all the mix. Otherwise, there's no purpose. Then there's all the details of how then to make it stick, how to maybe make sure that you can get around corners. How do you spray upwards? Do you impact the mold? Because compared to other materials, like a steel reinforced concrete, the fibers are flexible. That allows you to tamper with the mold after spraying it or putting a premix in. So you can even tamper that. How much? When? Is it just after sprayed? Is it an hour later? Is it 20 minutes later? And how would you do it? And what does that make to the surface? All this is all the tricks. And that is my point. And that's a long answer. It's the handcraft.
Yeah.
It's just so damn difficult. It's when you see a guy that works with wood and you can just tell, I couldn't do that. I just couldn't do that. But you can see that somehow when he's working with it and he's making the nice, I don't know, oak wooden table, and you see, oh wow, this guy really he's a craftsman.
Knows his trade, he's got the experience.
It's the same with GRC. When you're in the industry for a while, you can also see who knows what they're doing. But there's a lot of capable guys out there that are really, knowing a lot about concrete, that are capable with all the tools.
Yeah.
But there's so many tricks to it. And that is the difficult thing.
It's the key thing to understand.
Is that, do the manufacturer have, the guy that makes that, does he have the training and the experience? Is that the know-how is it a completely new? And that's the next thing that GRC is seeing right now, is that it seems as area architects want to make it even crazier, even wilder, even, now you're talking about green and things like that you want to, push the limit all the time, which is also,
there's very much, in the UK, there's very much two sides of the coin, because, some people I will speak to who think GRC is still new, you know, and I'll explain to them it got installed here in 1974. It is most definitely not a new material to the UK, but to a degree it has been kept very complex, very mysterious, very secretive in the UK, which is something that as a business we're trying to sort of, you know, I suppose, not necessarily educate the market. We're just trying to talk about GRC more. We're trying to be in the right places. We're trying to let people know who the professionals are, who the manufacturers that are supplying a lot of material here. We are sort of bridging the gap, between the customer and, and the supply.
If this table were the market of facade, GRC would be, this tiny little corner here in the corner of the table.
Yeah.
I mean, whether that would be even double, the market wouldn't even fill it.
Yeah.
So GRC is, I mean, working with it every day for 12, 13 years now, and then coming into another one saying, I've never heard about the material, and it's happening again and again and again. So it's one of those, how to, why is that not more common knowledge to people that know, oh, but fiber concrete, is that something you put in the floors? Well, it could be, because people put fibers in the floors as well.
Yeah.
You can use it, and that's back to the first, that you're also getting confused about, is it a material, is it a product? And that it just takes really long time for a new material to find its foothold.
Yeah.
When you have a, let's say, very legislative or bureaucratic market, like the UK or the Scandinavian for that matter, European in total, I would say, you have a very high liability for the one who makes the decision of the material. The material decision company person. Is it the contractor? Is it the designer, the architect? Is it the engineer? Or is it just, the lad there that, I just need to put up a door here that can be a steel door, wooden door.
Yeah.
It just says door. I'm now making the decision on the material. And in Scandinavia, at least, we say that every 10 years, on average, we get like a big slap in the face on something that has been a wrong choice.
Yeah.
We have asbestos. We have, I don't know what's the right word in English, but eternite. It's like a small little roof system that went wrong. And now we have some MGO plates that are windshield plates that are not suitable. And that's within the last maybe 35, 40 years. And it takes, then 5-7 years of a lot of lawsuits and discussion, maybe some bankruptcy to find out.
Before the change.
And what then happens is that you tend to be very conservative, opting in for new material. And I fully understand, if I were head of a design studio and the new interesting young employer came in and she or he said, oh, GRC is the new thing, let's do this. Say, and there's all these appraisal for it, and look, this tested. Yeah, I've seen that before. Put it on a building, let it stay on a building for 50 years. Then I'll put, then it won't be poorly
it won't be
specified. It can either be poorly manufactured or poorly installed, but it's not poorly specified or poorly decided as a material, because it sits down there for 50 years and it works.
And it's working, yeah.
So when you have that liability built in your market for whoever decides on material, you of course have a very conservative approach. This is, by the way, also a reason why you see that a lot of the new green tech that probably is a lot needed, let's use all these green, materials that are out there, is having a difficult time getting into the market. Because people are, let's see it.
Let's see some other people do it first.
and that's, at least that's what that theory there I just presented is what I'm clinging, I hope, to. Why is it that GRC is not even more specified?
Yeah.
And then you have that weird situation in the market where you then actually have some projects where it's specified to a quantity, an amount that are so big that no supplier, no manufacturer has a reasonable chance. Yeah. And the best example is obviously when the Crossrail project came to light, and it was all 7 stations covered in GRC, complex GRC, and the main contractor, Lange Rourke, simply decided to purchase a GRC manufacturer, GRC UK, and that's a clear sign of who could even supply this. And to be fair, GRC UK then supplied a few stations, but not all of them. You would even then have sub-supplies. And the point I'm making is that you still see that. And that's one side of things, and you also see that big companies are stepping in, and then they're regretting it, back to the craftsmanship.
And none of it helps. None of it helps the reputation that GRC
that doesn't
has,
help.
yeah.
At least not. And you see that with you know that how both now I mentioned by name a contractor that stepped in, kept the name, kept probably the capabilities, but as least I know, not manufacturing that right now. And you have another big brick manufacturer stepping in, heavily reducing and focusing on other things, but still having, maybe using the know-how they obtained by that purchase. And you see that not as, a comforting thing for the material, and that's back to the sizes and to the craftsmanship of things.
That's been a big thing here in the UK. It's something that I've addressed head on. There's been no secret about it that the UK's main issue with GRC is not the material. There are not horror stories about the material itself. As you say, it has been the horror stories about the supply chain paucity, about people joining and leaving, which again, when you say are some very sizable companies, it leaves a ripple effect in the market with a question mark over GRC. But what I have seen in the last sort of 3 years, the specification demand for GRC here in the UK has been, is growing exponentially. It is massive compared to what can actually be supplied here, which is why I've, my business has 2 focuses really. It's my daily sort of activities are sales and specifications of GRC. But second to that, I'm also working with a lot of organisations within the UK construction industry to actually bring together the GRC professionals in order for us to sort of set a bar moving forward for people who are not familiar with GRC, architects, designers, contractors that do design and build projects. So if you're not somebody who's aware of GRC and you don't know where to turn and you don't know who the professionals are or who make GRC well and so forth, we're going to put together a document that will hopefully be a sort of a benchmark for people that are not already familiar to use, to understand the material, to understand how it's made, its limitations, its capabilities, and actually be a sort of, something for the market to use as a tangible, valuable document, because that isn't really here at the moment. We've, long before GRC, Link GRC, there were amazing manufacturers that are amazing GRC professionals. There are really fantastic contractors that want to use GRC and architects who want to specify it.
And a lot of references, a lot of big buildings that are really beautiful.
But that there isn't anybody, or there wasn't anybody sort of pulling that together. So in Link GRC, that's what we are trying to set a sort of a benchmark for, really, the collaboration and the bold new thinking within the GRC market, so we can take it from what is currently a niche architectural system, specification, to something that is more commonly used and understood, particularly on the back of the sustainability benefits that you can get from GRC, the weight savings, the faster installation, the fact that you don't require the same site storage as you perhaps would with a brick slip system, or some of the other systems that can be used. If you're in central London and you don't have site storage, GRC can arrive and it can go onto a landing bag, onto the facade. So there are many benefits that I think have almost forced the UK to have to sit up and listen to GRC. And at that time, that's, what the market is asking for is guidance on it. So hopefully that's, where we're heading.
I was just about to say that I'm sitting here nearly trash talking GRC, rewinding myself on saying, it only has to be about craftsmen and but the point is, when it's made right, it's a superior product.
Yeah.
We have this typically saying in the industry where you say, it doesn't rust. That's of course a little knife to all the steel reinforced concrete. Oh yeah, but we just put a big layer. Yeah, but sometimes the water will get in there
And it
and
will
oh, I
rust.
just put some really good concrete in. Yeah, or some really good steel, but it does deteriorate. You have then to come back and test it. How do you test it? Well, you can't other than cut a hole and look how the reinforcement have it. It doesn't make a noise. What do I mean by that? Well, especially on high rises, you can have a movement when there's a lot of wind that'll make a noise. And concrete or the GRC does not make that. It's actually even used for interior music halls for acoustic, because it's actually, when it's pointed correctly, it's really good. And thirdly, it doesn't catch fire. So if you have a material that has very low maintenance because it's colored through and has a long durability, it doesn't make a sound and it doesn't rust, and you could still make it in interesting curvatures. Well, that's very superior to any other product. I mean, you can find things with interesting curvature. You'll probably have issues with other things then. And this is where GRC is that popular, and you see that exponential rise in market demand, as you mentioned. But my point was just that the size of the jobs is like running faster than the industry, because the industry having this shortcomings of it's deceptively easy, so maybe also that's why. But you've seen some come in and thought, okay, now we're gonna make it big so we can meet that big demand. But it has to be a little bit more organic. And you have to find a way. And I think the answer to all that, where will this end, is obviously automation. I mean, it's very handcrafted material right now. Do I believe that the answer is coming next year or tomorrow? No, I don't. It's really difficult to see that. But the way the world is developing right now in visual recognition and how we can have robots standing next to humans and helping, that's the way. Probably first which is already happening quite a lot, in the mold making, because that's a whole industry of making molds to all sorts of things, concrete as such, but also GRC. That's more and more automated. But also the actual manufacture will get more and more part of the process, but slowly more and more be taken off. Of course, some companies are already on that path right now, making things they can do. That could be the grid blasting. That can be the if you grid blast the panel next morning. It can be the washing off if you use a retarder to wash off. It can be the putting the slip agent in the mold. Things like that could of course be automated, but also slowly more and more the actual material. Obviously, the mixes is already on the majority of high-end manufacturers is automated batching systems now. So you got all these processes being, and that's where I think the answer is to when do that bridge is then built between the market demand and that kind of constraint that is that we need craftsmen. Well, it's actually automation. I think that then you can have that, as long as you fully understand the automation and have the money to do a lot of errors, and it happens every day now. More and more things in the process is being slowly taken over by automated systems.
So for architects or contractors considering using GRC for a project, what would you say is the best advice you could give them up front?
Well, I think that goes with all the decisions they have to make, the purchasers, is that the sweet taste of a good price is nothing in comparison to the bitterness of poor quality. And
good to hear.
I mean, the thing is that the issues on site, it just have to happen, the tiniest little thing, or just the mere discussion, and then you saved, a part of
problems,
let's say some percent on a part of your. So of course I'm not saying let's buy the most expensive. That's a competitive market, and you're also you need to earn something as a contractor or if it's a developer that are supplying the material, I get that. And of course, there's there's a fight there, but it is hard for me to see sometimes that you develop things with high-end manufacturers, maybe in UK, and you have your samples, you have the whole, and then at the end of the day, you think, why would I pay that if I can pay, can save a part of that, and then I just get it from elsewhere.
Yeah.
From a manufacturer that is not maybe that skilled exactly in this. And I see that sometimes.
Yeah.
So I'm not saying go buy the Lamborghini every time. I'm saying
cheap is not always good, especially in GRC. How I address that when I'm out speaking to people, because cost for GRC is something that people mention very frequently. For me, when I'm explaining that, it's like anybody. I ask the architect, the contractor, whoever I'm speaking to, put yourself in your own shoes. So if you was having a kitchen renovation for your home, and you've decided on your specification, this is how you want it to look, these are the work surfaces, these are the cupboards, and you get a range of 2, 3, 4, 5 prices. Very rarely would somebody say, okay, these 3 guys here are pricing my kitchen at 10,000, and these 2 are pricing it at 2,500. Very rarely, when somebody's making a choice for their own home or for their own product, would they choose the very, very low one, because it often comes, like you say, with different labour processes, different materials, different supply chains. So I totally agree with you. We're not saying always pick the top price. It does have to be competitive, particularly for procurement teams. And the larger the project, the more important price can become. But I have a saying, which is nothing is cheaper if you pay for it twice. So that's what I ask people to keep in mind when they're thinking of
that's a fair saying.
Of the pricing, yeah.
That's a fair saying. And obviously, the more practical advice would be calibration of expectations. And that is, GRCA have a specifier's guide. It's the least downloaded document. And it should have been the most downloaded document.
Yeah.
Because it encouraged people to discuss what is this material main properties that I need to be looked out for. Is it the tolerances of the backside or the fixings? Because that's common. Is it the color differences? Is it the sizes? Is it corners? What is it? And if it's all of that, well, it could probably all be achieved, but the supplier would have then to allow for a higher discussion rate. It has to allow for a slower production schedule. It has to, why? Well, because you need to then look out for your mold more times. When I say look out for the mold, means that you need to maybe send it back to your mold shop for redefining it or for checking it. And all of that comes with both cost and time.
Yeah.
And that is the big thing is obviously to accept that, the time.
Yeah.
So expectation calibration, having those talks, and you can use a like you or others that are making that forum or helping those calibration on the way. They're also on smaller jobs. If you're too costly, I'm too costly, anyone else too costly, then there are all these tools out there to have that. And it's not enough just to have a specification copy of another specification with your CEO. That was a good specification, put that in. Well, you have to look at it on not over specifying so it's too costly.
Yeah.
To really
but not doing the bare
take
minimum.
those meeting with the supplier. Okay, this is my specification. Let's go through them one by one.
Yeah.
How will you obtain this? No, this is not really that important for me. You give me a price reduction if you don't need to do that, but I need you to do this more because this is the key on my.
That's the project driver for your specific site.
And it's to understanding that project, taking the time for that is I think it's my key advice for both the specifier and the purchaser.
And I would totally agree. And I think again, on the specification side of things, I think when people don't understand what the specification should look like, I think that can be very off-putting for people that were considering to use GRC. Sometimes, I speak with architects that had every intention to sort of address GRC as a material, but quite frequently I will hear, oh, we stuck with precast because we understand it, or we changed it to aluminium because the designers have made that choice, even when GRC was really probably the best solution for the project, which again is something as Link GRC, that's what we're trying to be. Before we opened Link GRC as a customer, whether that's an architect or a main contractor or an installer, for a customer wanting to specify or procure GRC, they have to speak direct to the manufacturer, which, as you will know, if an inquiry is sent to a manufacturer and it isn't the particular type of inquiry that manufacturer wants to produce, or if they're at full capacity, that manufacturer would never pick the phone up and say, but my competitor down the road or somebody else in Europe, or here's somebody who would look at that scope. So I think a lot of GRC specification opportunities are sometimes lost because the client didn't have anywhere to go that was independent and non-biased. So that's what we're trying to sort of create in Link GRC. A customer can come to us and say, this is the project, this is the intention, or this is the design intent. Where are we at? And Link GRC will speak to multiple manufacturers that, have the capabilities for that size of scope, that have the interest to want to price that work. And it is actually Link GRC that will provide that seamless customer service, so the client isn't left hanging, wondering if GRC, was viable or if it was within budget. We try to sort of take that project and look after that client, regardless of which route they're going to go. We try to ensure that they are sort of connected with the people who make GRC well, who understand GRC technically, who provide systems that are safe, that are aesthetically pleasing, and that are of good quality. So that's something that we're sort of trying to help, sort of put out there in the GRC market. I think the final question I've got for you today, Simon, would be, what would you say is the most underestimated thing in the GRC industry that still happens or that's not spoke about enough?
It's happening on every single project, and it's time. Accepting time. So the facade is typically part of the last thing on a building, and you've already lost a lot of time on all the other things you made wrong with your escalator and your escape routes and your whatever. And then and you have a handover, and you need to get rid of that, because otherwise the landlord or the authorities will come and kick your teeth out, and everything is stressed. And you're at the very end and everybody wants it to be finished. And GRC has to cure. Mm-hmm. You can sit there and blow at it. It has to cure. Yeah. It has to cure in that mold, and it has a certain tempo of that. Yeah. And of course, you can try to put accelerators in. That will go against quality. Yeah. Because the strength will be hurt somewhat of it. But you could have, higher temperatures, but then that's pretty much the same. So a typically standard would be that if you had the exact same mold, and that mold would be a good high-end quality mold, you can make that same panel once a day, allowing for a few discussion. That's maybe 5 in 14 days if you allow for weekends. Otherwise, you can make maybe 10, 12 if you're also casting during the weekends. And that is if it's the same. Yeah. But when you have any job, you're not having the same. That's the whole idea of making it with GRC. And you have more types than you are. So you have to make those molds in either remake the molds or make new molds. Yeah. That takes a lot of time as well. Yeah. Why don't you just print the molds? Well, you of course already print parts of the molds. Mm-hmm. You're already using CNC milling systems to make part of the molds or the mold, and you use the rubber mat, you can use bended steel, there's so many things inside a mold. Yeah. It takes time. Yeah. And you can do none of that. You can't make even the base layer of the mold, because why can't you make the base layer? Well, you need that hold where you sit there and make that planning. If I make this panel first, I can then cut that mold down. That'll be faster for you in the end.
Yeah, well,
If I
it's
get all
faster for the manufacturer and also cost effective for the client if it
obviously
can
also
be
cost
manufactured
effective.
in the
If
optimal.
the contract is written in a way that allows what it typically would, you're right. And then you have at the other end, you have these. We just need to get this east facade finished, and then you make the east facade and you cut down the mold, and it's it's the replica on maybe the north side.
Yeah.
And now you end up spending material and cost, not least time.
Yeah.
And that's only in the process of manufacturing. Just prior to that is the time for the good design.
Yeah.
And that good design phase seems to take longer time, apparently, every time.
Yeah.
Every time I see these, then we do, we design here, engineer will decide, color will be documented, surface will be agreed, and then you pretty much write production next day. Wow, okay.
Yeah.
And I see that all again and again and again. And I mean, the amount of jobs I've seen coming too late, and that's a big part of the discussion.
Yeah.
And then, that also take a hit on the quality, obviously. Because you gotta accept something, or the supplier has to, I can't remake this because I just gotta send it to him. And compared to the time I've seen jobs well done, well ahead, it's only very few jobs, and I've been involved in hundreds of jobs. So it's really, really weird that, and every time you sit in the forefront of it, this job will be different because we have this planning system and we have this really understandable, very experienced developer, and I promise you this time. And it's so rare to see. So my advice, my big shout out is allow for the time. And I know a part of that is, but it's costly to have the building site. You don't need, because this is off-site manufacture.
Yeah.
You just need to start that process way earlier.
Early enough, yeah.
You need to start that when you're discussing all the other things. Once that's decided, start that whole thing, because that just takes time. Then you can discuss your, fire cavity barriers and your windows and all. I know that works in between each other, and you can't discuss one without the other.
But you're quite right.
But I mean,
in the UK, it's stage 2, really. Design concept is where we say, as a UK market, that GRC needs to be thought of, because if you're using it on a large scale facade, if you don't include it at stage 2, you've often missed the opportunity to take the weight off the structure. You've missed the opportunity to thin the floor slabs. Yeah. So stage 2, talking of time, stage 2 design concept is where GRC, needs to be thought of. Thank you very much for coming to the podcast today, Simon. It's been absolutely fantastic to have you here. And episode 2 will be out on the Link GRC Limited YouTube. Thanks for having us.
Bye.